Hello friends, my name is AJ and welcome to the 5th video in Carolina Analytics and Data Science's Introduction to Python for Data Science series. In this video, we're going to be talking all about making decisions and evaluations in Python. And we're going to be specifically talking about Boolean expressions and if statements. So without further ado, let's get started. All right, everyone, so here again, we have a empty Jupyter notebook with three main sections. And the first thing we're going to be talking about is working with Boolean expressions. Now, what does a Boolean expression actually mean? Well, we can look at the first word of this, which is Boolean. And I'm going to recall now back to video 2, where we talked about the different data types that our variables can be. And one of the data types was a Boolean. Now remember, Booleans are unique because they can only have two possible values. That is either true or that is false. And I referred to this kind of as a binary choice. Think about like a light switch, right? You have on or off. There's only two possible positions that it could be in, nothing else, right? True, false, on, off, yes or no, right? That's another example where you have only two options. So that is essentially what a Boolean is. And we can create variables that are Booleans simply by creating, for example, my bool equals, and then I can either put in true or I can put in false as the value. Again, just to refresh here, I'll write it. We're using the name equals value. This is the basic standard way that we define variables in Python. And in this case, we are creating a variable named my_bool, which is short for my Boolean. And the value for this variable is going to be false. Now remember, true and false in Python are represented by true and false with a capital first letter. So capital T and a capital F. Now, here you can see that we can assign our variables to be true or to be false, right? However, that is just one way that we can actually create Booleans. And this is going now to the idea of a Boolean expression. And a Boolean expression basically allows us to examine or to evaluate whether a statement is true or false. Whether it is true or false, which matches up with the two possible values for a Boolean, either true, false. Yes, this statement is true, or no, this statement is not true, or it is false. Now, what are examples of statements? Well, statements in this case, and evaluating statements, are referring to comparisons between two values. So I'm going to be writing here, this is involving comparisons. Now, what type of comparisons can we make? Well, let's say we have a certain number. So I'm going to say that the age here is equal to 20 or 25. And let's say that, actually, let's do age of 8. And let's say that you can only use the children's menu at a restaurant if your child is less than the age of 12. So I'll say here that this is going to be children's menu cutoff. And I'll say this is equal to 12. Well, what if now we want to try and evaluate whether or not our child, which is in this case age 8, can use the children's menu? Well, when is that true? When can we use the children's menu in this case? Well, we can use it if our age is less than or equal to, in this case, our cutoff, which is 12. And that is where we get the idea of comparisons. Right? So in this case, I can say age less than our children's menu cutoff. You can see I'm using the less than symbol. And if I were to just print out what Python thinks of this, you can see it gives me true. Now this is kind of interesting. I'm essentially saying age less than children's menu cutoff, and it gives me the value of true. And we can test to see that this is a Boolean by using our type function. And you can see that this, when we take two variables and in the center we add this less than symbol, it gives us a Boolean data type, which is taking this expression and saying whether it is true or not. let's say I change my age. Let's say that all of a sudden I am a 15-year-old and I'm trying to use the children's menu. If I run this cell again, well, okay, this says that it's still a Boolean, so that's good. Now, if I use the print statement to get the value of this comparison, you can see that Python says that this is false. Why? Well, the age in this case, which is 15, is not less than the menu cutoff, which is 12. And therefore, Python is evaluating this as false, or as a Boolean, which is false. Now, this is just one type of comparison we can use, and this is the less than. So I can say that we have less than, which is using the less than symbol. We have greater than, which uses the greater than symbol. Now, if you wanted to say less than or equal to, because let's say that our age of our child is 12 years old. If I were to run my cell, you'll see that it still gives me false, because 12 is not less than 12. It's equal to, but it's not less than 12. So because of that, in this case, our expression is assuming, for example, that children who are 12 years old and higher are not, or I guess people 12 or higher are not considered children for the children's menu. However, anything less than 12, which is anything like basically up to 11 years old, does count. But let's say we want to actually include 12 years old or 12-year-olds in our comparison, then we need to use less than or equal to, so that it can either be when the age is less than 12 or equal to 12. So we have less than or equal to, which is referred to using the less than symbol, and then right after it, without a space, the equal sign. Less than or equal to. You can see if I change my operation now, right over here, or comparison operator, you can see that when I run this, now the value for my expression is true. The reason it is true is because 12 is either less than or equal to 12. Now, in addition, we have, just like how we have less than or equal to, we have greater than or equal to, which is going to be the greater than sign followed by, you guessed it, the equal sign. But now, what if we want to compare two ages, or let's say we want to compare two values and see if they're actually equal? So actually, let's say that I have a password guess, and let's say that I'm guessing that my password is, let's just say 1, 2, 3, 4. I'm guessing that that is my password. And the actual password, right over here, is going to be 4, 3, 2, and 1. Now, instead of using less than, greater than, less than or equal to, greater than or equal to, what if we want to just compare if two variables have the same value, or if the values are equal to each other? And to do equal, you might automatically assume that we just use a single equal sign, and that might work, you might think that it would work. However, I want you to take a look at all of these lines where we actually define variables. And you can see that when we define variables, we use an equal sign already. This is what's known as an assignment operator. We're assigning a value to a variable, and we use a single equal sign to do this. You can see here, here, and here. So how would Python be able to differentiate the difference between the assignment operator and a comparison operator? And that is why when we are trying to compare values and we want to represent equality, we need to use two equal signs, just back to back, just like this. Now, this is something that a lot of people, especially in the beginning, might get or might accidentally forget. Like, for example, if I were to do print and then password guess equals actual password, you can see that it gives me a complete error here. It doesn't allow me to compare the two. However, when I use a double equal sign, now you can see it actually gives me a value. And of course, in this case, because I have two print statements, the print statement for this comparison is going to be the second one. So you can see that my password guess is not equal to the actual password. However, let's say that I change my guess and I actually type in 4321. Now, if I were to run my cell, you will see that it actually prints out true, because the value of the variable on the left is equal to the value on the variable of the right. So 4321 is the same as 4321, therefore this value is true. Now, just like there is equals, there's also not equal. So that is here not equal. And not equal is simply exclamation point and then equal sign. Yeah, this looks a little bit interesting. So now if I were to change this to an exclamation point, oops, you can see when I run this, it now gives me false because my password guess is not equal to the actual password. Or in this case, it is equal to the actual password. And because it's equal, then my statement, which is saying if password guess is not equal to actual password, then it would say that this statement is true, which in this case, it isn't because this is actually equal to this, making this statement not true. So it is false. Now, again, when we're working with not equal, thinking about this, logically might be a little confusing, especially when I'm starting to use these type of things, because I'm essentially saying that if these two are not equal, then it evaluates to true. And if they are equal, then it evaluates to false. So that is kind of the difference there between using equals and not equals. Now, just for the sake of this, I'm going to change it back to equals because it makes sense for the context of this problem, where I'm trying to, for example, type in a password, and if it is equal to what the actual password is, then it might let me log in or something. And so there you can see that now it prints to be true. Now, we can actually do more things with this. We can actually combine different Boolean expressions together. You can see here that this is the example of a Boolean expression. And also one thing I think that I will add here, just to note, is that I can actually say, for example, my second bool, I can actually set a Boolean variable to be equal to one of these expressions. So I can just take, for example, this age children's menu cutoff, and it's now going to save the result of this to this variable. And if I were to print out the value of my second Boolean, you will see that it prints out the value of true. Now, if I were to change the function to type, you can see that my variable that was created is a Boolean. So anytime you use these comparisons, less than, greater than, less than or equal to, greater than or equal to, equals or not equals, then the final result or the final value will be a Boolean. So now we can go to what is known as compound conditions or compound conditional operators. And essentially what this is this is going to be taking our actual comparisons and almost adding them together, right? So let's say I have two conditions, right? Let's say that I have a special children's birthday special for a restaurant, okay? Now that is, that is a little bit interesting. So I'm going to write this down. Children's birthday special at a restaurant. Okay? So the first thing that I need to count is, well, what do I want children to be? Well, you're a child, okay? You're a child if the age is less than 18. Let's say we just use less than 18 for this one. And birthday, it is a child's birthday if the birthday is, if it is the child's birthday, right? Just like that. So that is, these are two different conditions here in order for this to be true. It not only needs to be a child where the age is less than 18, but it also needs to be true that it is the child's birthday. And this is where we can use connectors, okay? We can essentially combine conditional operators together. Now, how do we actually combine them together? Well, there are a few logical connections, and the two main common ones are and or, okay? So what and refers to, so let's say I have A and B. This is going to return true if A is true and B is true, and false otherwise. All right? Now, if we use the or, so if I say and or B, then this will return true if A is true or B is true, meaning that if either A or B is true, then it will return, then it will be true, otherwise false. Now, when I'm using or here, there are two different versions of or technically in the English language. Or can either mean like only one of these has to be true, or only one can be true and the other has to be false. Okay? In this case, when we're using or in Python, any of the either A or B has to be true. Now, both of them could be true in order for our function to return true, but only one of them needs to be true. So any of these have to be true in order for the entire expression to be true. Okay? So I'm going to show an example. Let's say again I have my age. So the child age, let's say that this is equal to 15. And I have now birthday. And now birthday, right, can actually be a Boolean itself, right? Think about it. If we can represent whether it is a child's birthday using either true or false, yes or no. Yes, is it the birthday? Right, true. Or no, it's not the birthday, false. So let's say in my case, I have the birthday set to true, meaning it is a child's birthday and their age is 15. Well, we can now create a compound expression. We can say that if the child age is less than 18, and I'll actually change, I'll keep this less than 18. So less than 18, right? And then we also have if it is the child's birthday. So I can simply say birthday, if birthday is equal to true, right? And now we need to connect both of these. We need to connect both of these individual expressions. Now, how can we connect them? Should we use and or should we use or? Well, in this case, in order for this to work, it needs to be and, because the child's age needs to be less than 18 and it needs to be their birthday in order for this special to work. So therefore, we can use the and operator. And you can see in this case, when I run my cell, it returns as true. Why? Because the child's age is less than 18, which is true. So now the left-hand side is true, and birthday is equal to true. So the right-hand side is true. And remember, when we use and, if both sides are true, both A and B are true, then our overall expression is true. And that is what is being returned here. Now, if one of these becomes false, let's say that if I change birthday to false, then if I run the cell, you will see that my expression changed to false. Why is this? Well, here my first expression, child age is less than 18. Well, my child age is 15. So that is true. 15 is less than 18. So the left-hand side is true. However, take a look at the right-hand side. And birthday equals true. Well, in this case, my variable birthday is equal to false. So false is not equal to true. And because of that, the right-hand side of my expression is false. And remember, for and, both this side needs to be true and this side needs to be true in order for the entire thing to be true. So because this is false, or this expression, birthday equals true, is not true, it's false, then our overall expression will return false. Now, if I were to change this to or, you will see now it is true, because with or, you only need at least one of them to be true. So in this case, because the left-hand side is true, it doesn't matter whether or not the right-hand side is false or not. The entire expression will just evaluate to true. So that is using, that's an example of using compound conditional operators. Being able to allow us to essentially take many different conditions and string them together. All right? So that is basically the entire thing behind essentially taking many different Boolean expressions and combining them together. Now we get to one of a very, very fundamental part of programming in general, as well as data science, and this has to do with the if statement. Now, what does the if statement mean? Well, the if statement in our code allows us to do something. depending on whether a condition is met or not. All right, so I'm going to show you the basic structure, and then I'm going to explain it. So the way that an if statement works, and I guess I'll write this down. So an if statement, right, runs certain code if, again, keyword here, if a certain condition is met. All right, so how do we write an if statement? Well, to write an if statement, we need to use the keyword if. You see, if I type in if in my code, you can see that it turns to a bold green. All right, and then after the if statement, you want to write your condition. If condition. And then you add a colon. And then underneath, all of your code that you want to run if this condition is true is indented one step in. So this would be run code here. All right, and that is essentially the format for creating an if statement. Now we need to obviously fill in some of the gaps. So let's say, well, if I want to write an if statement here, so let's say I want to use actually I'll go back up here and I'll use this very basic one, age equals 12, menu cutoff equals 12. So I'm actually just going to copy this down, right? If I run this again, you can see that this evaluates to true, right? But now what if I want to run code if and only if this particular expression is met, or this condition is met, the fact that age is less than or equal to the children's menu cutoff. If that is true, then I want to do something. And in this case, I want to print out that this child is eligible for the child's menu, or this person is eligible for the child's menu, right? Children's menu. So what we can do is we can use an if statement. We can say if condition, right? And then we have our code below. So I'll say run code here. Now, what is our condition? Well, the condition in this case is if the age is less than or equal to the children's menu cutoff. So all I have to do is I just have to copy and paste this right in here. So what goes in the condition spot for an if statement is a Boolean expression. That's why we learned how to do this and how to make comparisons, because that is a condition. If the age is less than the children's menu cutoff, then we're going to print out, okay, that this person is eligible for the children's menu. Just like that. And now if I were to run my code, and actually what I'm going to do is I'm going to put this inside of my original cell so that I can run this at the same time. All right, let me just delete these cells real quick. And if I were to run this, you can now see that it prints out this person is eligible for the children's menu. Why? Well, my condition was met. The age is less than or equal to the children's menu cutoff. And because of that, it runs the code inside of my if statement. Now, let's say this wasn't true. Let's say that I put 25 as my age. If I run my cell, you can see that nothing prints out because this condition here was not met, none of the code inside of the if statement is run. So I can have many things. I can say print, A, print B, right? Just like that, print A, print B. But then if I have outside, I usually have something unindented, print C. Anything that is indented, one step inside of the if statement is going to be tied to this condition. If I were to run this code when my condition is true, so let's say I've set my age to 7, now it will print out all these things. It'll print out this person's eligible for the children's menu. It'll print out A, B, and C. However, here, if I change this to where the age does not work, let's say again 25, and I run my cell, you'll see that it's only going to print C. And that is because all of this is indented and part of my if statement while this is not. Now, what if you wanted to run code if the condition is not true? Well, what you can do is you can actually add something called an else statement. And an else statement looks just like that. You type the word else. So I'll write this here. Else. Right? Else and then colon. And then this code runs if the condition is not true. And then I guess here, this code runs. This code runs if the condition is true. All right? So now in my else statement, I can, for example, say print, this person is not eligible for the children's menu. just like that. And now when I run my cell, because this condition is false, age is not less than or equal to 12, it will print the code in the else statement rather than the if statement. And now the one last thing that we can do here is, let's say that I have another condition. So I want to say, okay, well, if this condition isn't true, let's test another thing. And that's when we use the elif keyword, which is shorthand for else if. Okay, so you're essentially saying, okay, well, if this condition isn't met, let's try another one. So this would be condition 2. This code runs if the second condition, or if the second, well, if the first condition is false, and this second condition is true. Just like that. All right. So for example, let's say I change this to less than, and I have now an else if my age is exactly equal to the children's menu cutoff. Children's menu cutoff. And I want a custom message. I can say print, this person is eligible for the children's menu, but not for long. Enjoy while you can. Just like that, with maybe an evil face. All right, so this here will now only run if the age is equal to the cutoff. So if I run again here when my age is 25, it's going to run the else statement because this condition wasn't true, then this condition wasn't true, so therefore else. Now if I change this back to 8, you'll see that it only runs this because our first condition was met, so it runs the cell here. It's now not going to check this if statement because it only checks this condition, remember, if the first condition is false, which in this case it wasn't. Now if I were to say 12 exactly, now you can see that it prints out this statement here because the first statement is age less than or equal to the cutoff is false. 12 is not less than 12. So then we go to the next statement. Age is equal to 12? Yes, it is. So now we run the code inside of this if statement. All right, everyone, that is it for Boolean expressions and if statements. If statements are so useful in data science and when making decisions. Comparing values especially is very, very important, especially as we start doing more advanced work. Thank you all so much for watching. If you liked the video, feel free to like and subscribe for more content. Make sure to follow CADS on Instagram as well as join our Listerv for the most up-to-date information on the organization. And see you all in the next one.